thanks everyone for being here. Yeah, so this talk is why Haskell is a terrible choice for startups, so why we picked it anyway. Despite the incendiary clickbaity title, I'll try to give kind of a balanced view on 4 years of Haskell in production and how that's gone. Just to introduce myself here really quickly, so I'm the founder and CEO of Scarf, and what we do is usage analytics and sales intelligence for open source software companies. The whole backend is Haskell. It's definitely running at scale, serving almost 200 million software package downloads globally every month. And that's now about 350,000 lines of Haskell code in that code base. But I've personally been a Haskell developer for quite a while now, and this is kind of how it's played out in practice of building a big project with it. So when we're trying to evaluate what is a good language choice in a startup, I think it's just important to start with, well, what do we actually care about if we're trying to pick technology for a startup environment? And I think my personal opinions on this really evolved from being an engineer into being a founder and CEO of a company. The criteria has kind of shifted a lot from that perspective. But really when you're trying to get a company off the ground, number one thing is that you're trying to find product market fit and build that business as quickly as you can. Like the clock is running, the bank account is dipping, and you're trying to move as fast as you possibly can to find a product that brings value to your customers. And so the speed that you are shipping code is really, really important. And also your agility of your product that you can adapt to changes quickly may make or break your success. You're going to start out with something that may look very different from the thing that you find that's actually successful when you find product market fit. Of course, it's not just building a product, but you're also trying to build a great team very fast as well. So maybe you have a great network that you're starting with, maybe you don't, but one way or another you need to get really good engineers on board. Once you do have that team and you have the product, or even before the product, you need to focus just on your priorities and nothing else, and keep costs down while you're doing it. And all of this is a lot of work. And so making sure that you're doing this in a sustainable fashion, not burning yourself out, is also very key. And a lot of things that I think we traditionally talk about when we talk about programming or just developer philosophies that may not matter as much here in this context. Things like correctness and finding perfect extractions and beautiful code. All things that we like to talk about and care a lot about in terms of our craft as developers. But those things typically are not really going to make or break the company as much as we might like to think. And so ultimately I think the things that we often focus on when we are talking about programming, when you zoom out on your business and you're trying to figure out whether your business is going to be successful, it's not actually really all that important. And I think, grain of salt here, I have much more radical opinions on this after kind of 4 years of getting a company off the ground. And so when I was trying to get Scarf started, Haskell's my favorite language, and of course, let's just use Haskell. How hard really is it going to be? But we found out the hard way, and here's all the lessons from that. And so I think the first thing that comes up a lot when we talk about Haskell in a company is the topic of hiring. I think it's a pretty nuanced topic with a lot of pros and cons here. And so when we first raised money and were originally trying to hire our first engineers, we could literally just put a job listing up on Hacker News, and we get about 100 really, really good applicants. It's super easy because people would rush to you that there's a Haskell job, I want that Haskell job, and you get developers showing up just because the tech stack is Haskell. And that's awesome. And the other good thing is that when people apply, Haskell I feel like is already a pretty decent first pass. It attracts really great engineers. It has a steep learning curve, which actually works to your advantage here, that people have already gone through that. And a lot of people who care enough to learn Haskell probably care really deeply about the craft of programming and doing it well. I mean, obviously, generalizations, it doesn't apply to everyone, but in the aggregate, this has been true for us. On the flip side, though, we have to have the perspective of ecosystem size, and the reality is the talent pool for Haskell is very, very small. we were getting Scarf started in the middle of the pandemic. And so, the fact that we were kind of pushed to do a fully remote business was, I think there were a lot of factors that led to us doing that. But I think even if we had started Scarf at a time where the COVID was not happening, this probably basically would have forced our hand to be a remote company. It's very hard to find Haskell developers, specifically in your area, even in the Bay Area. We very rarely get applicants from the Bay. And I think the other thing here too is just that your average cost per engineer is probably going to be higher. That might be okay, right? Like you can definitely have a team of very experienced Haskell developers and get a lot done with very few people. But if you're trying to keep costs down, if you want to have a team that's kind of co-located, Haskell might not be the best choice. I think kind of one of the more obvious drawbacks to picking a language like Haskell is that you're going to run into missing libraries. You're going to run into incomplete libraries. And so one thing that we've been experiencing a lot at Scarf is that sometimes the technology choices that you want to pick or the vendors that you want to work with it may really conflict with your choice of Haskell, right? Like if you want to get payment set up, if you want to, run particular database providers that you want to work with, you may find yourself having to write the libraries yourself. You may find yourself adopting a library that's really incomplete, poorly maintained, and so that's a really tricky thing to work with. And so like we've had to write, we've used RocksDB, and so we had to publish RocksDB Haskell because that didn't exist. And that's a thing that you will run into often. And I think it's not just the fact that the libraries may be missing, but it's the fact that you have to make this decision every time you run into this of, do we pick a vendor that we don't really, want to use just because it's going to interact better with Haskell? Or are we really going to pick this database purely because the Haskell bindings are better? And, each time you have that discussion internally, that's kind of detracting from the thing that you're actually trying to do. And when it comes to the actual ecosystem sizes, I think this graph can really show that, like, despite the fact that I think Haskell has a lot of really great libraries, the overall size is just really, really small when you zoom out and see what the bigger picture actually looks like. And so, when I was writing code at Scarf, there were times where I was literally having to work late just to patch the Stripe library. And at the time, this has changed a lot since, but at the time, the Stripe library was using type families. It would take forever to compile just to add like one API endpoint to this library that we're like working late doing this stuff that is really not the core thing that I'm trying to do and solve. And so, the reality working in a startup is that you are working a lot. You're working all the time. And when you are, and this takes time out of your life to, do things that really are not the core thing that you're trying to do. Which I think, it sounds, that may or may not sound compelling in practice, but in reality, this has a real impact on your life as someone trying to start a business. And I think a thing that comes up a lot with this of just kind of doing this kind of extra work that has been solved in other programming communities is things like we are still missing a lot of the tools that come with Rails and Django and these really batteries-included web frameworks. And I think a really great example of this is an admin panel. A lot of batteries-included web frameworks have an admin panel where you can go and just modify the data structure or the data that you have, and kind of do the administering of your web app. You kind of have to build this from scratch in general in Haskell, although the caveat here is I think IHP is making a lot of progress on this, and so I'm really rooting for that web framework. But this is just one example. This kind of stuff comes up a lot where something that is kind of already solved in another ecosystem, you're going to have to probably do it yourself in Haskell. Another, I think, very common issue is that the compilation times in Haskell. I think there's a few pieces to that. So one is just the fact that fetching dependencies in Haskell takes a really long time, and so onboarding new engineers, if you don't have, if for whatever reason the cache has been blown away, you're just sitting around and waiting for a while. we had to do a really significant amount of work on our CI pipeline, and have kind of since largely solved this problem for us internally. But I think a lot of companies will have to go through kind of their own flavor of how you get your compilation times down, how you get your caching situation in order. But it doesn't really stop there, because you have to kind of continually have a lot of discipline to make sure that you're not adding, GHC extensions that are going to, take a huge slam on your build time. So especially if you start to get into some of the fancier type features, a lot of those things do not compile very quickly. And I think the other piece of this is that it has, and this is why I think there's a lot of Haskell projects that turn to Nix or Bazel or these other kind of things that are better incremental caching, but those come with a lot of upfront investment as well. And I think one of the points that I'm trying to make with all of this stuff is that while these are solvable problems in the long run, these are solvable problems if you have a lot of skill to do these things on your team. In a startup, you don't have the long run. Like, your business may die very soon, and you may never get to the point where these kind of long-term initiatives that will save you time in the long run ever come to bear fruit, because you didn't get your business in a spot where it was actually, gaining traction or, revenue and funding and all those kinds of things. And so these things like build times, for us, we had a really long discussion internally about, like, do we switch to Nix? Do we not switch to Nix? And it involved a really long migration over to it. And in the end, it wasn't super successful. And we kind of rolled back how much Nix we were doing. We were kind of going all out on it and walked it back a little bit to have a little bit of other tools in the mix. I think the other thing here that I'll say about this as well, this is one thing that is also making a lot of improvements just kind of in the ecosystem. When we started, we had to use self-hosted CI runners because GitHub Actions, for instance, didn't have runners with enough memory to build even a pretty simple Haskell application. And so, while some of these pieces may be getting solved over time, I think at large, you're still going to be dealing with a lot more complexity just in making sure that your build is in, you have a very tight feedback loop as a developer. So another really common thing is that dependency upgrades are likely to be very painful. For us, I think many of the folks that are writing Haskell here may remember the whole ASON upgrade thing that from GHC upgrades to library upgrades that you depend on, one of the drawbacks to having this really robust type system is that sometimes that causes brittleness. Things break eagerly because that's kind of part of the philosophy. Things should break if things if they're not exactly how the types have been designed. But with that comes brittleness. And so for us, what this looked like was ASON gets bumped up. We have to upgrade GHC. We have to do this whole migration, and this is the kind of thing that a lot of in a lot of other ecosystems, these kinds of things don't happen because there's stronger backwards compatibility guarantees. I think Go is a really great example of this, where they give really specific promises about what things will remain backwards compatible and for how long, and which things are kind of on the table to break. And that would be a really useful thing to have in the Haskell world, but we don't currently have that today. And I think that this was just kind of another time of just ASON gets bumped up, you're going to have maybe a very sad dog looking at you while you are coding very late at night. One of those things where it doesn't maybe sound like it doesn't matter, but in practice this is your life as a founder, as a programmer, whatever it is. This draws from your quality of life. This is going to make you burn out quicker. This is going to this jeopardizes the company. It really does. I think we like to think in the Haskell world that the types are kind of this this ground truth, and everything inside of our Haskell code base is pure and type safe, and everything is nice. But the reality is that takes a lot of work to do, and sometimes if you have those kind of very stringly typed functions. Sometimes you really need to get something out the door, and you move on to the next thing. And it's just another place where you can incur quite a bit of tech debt. And even if you spend all of this time, making sure that you have really, really sound types, a really sound model of your problem, it still doesn't really extend to the real world. Like one typo in the column name in your model, and you're going to have a runtime error. You might have type-safe routes in your API, but like in Servant, it still matters the order that you list those things. And there's lots of like very real-world spots where those types don't actually, make it all the way, to your front end or to whatever it is that you're building. And I think like, we dealt with this so many times. One of the spots is like, you may need to parse a UUID somewhere, and in one spot you're lazy and you just make it a string and you move on. And like those kinds of things, those kinds of paper cuts to your code base happen over and over and over. And I think it's just much more pronounced, that kind of tech debt in the Haskell world, because we want to, assume that we have these good types because we've, taken all the pain to use Haskell. And yet you're still kind of wrestling with, do I ship this thing really quickly and move on, or do I like take the time to make sure that these types are really, really good? And so I think like ultimately we've seen in a lot of spots, the really good type safety, you'll still have a lot of bugs and things that just break in ways that you wish was not the case. And so I think, when it comes to, this talking point of correctness, I think, one thing is like, how much does that actually matter in the first place, right? Like, how much does correctness really matter in our, in our space? You might be working on life and death software, and in that case, I feel like Haskell is a really, really great thing to use. But if you're trying to get product market fit for a company very quickly, you need to ship as fast as possible, and that's really kind of the reality of the situation that you might be in. And so, correctness is a nice thing to have, but it's not always the best goal in a startup environment as much as we would like to pretend it is. And there's, a really, you may have seen this kind of very prolific quote out there that, if you aren't embarrassed by your first product, you ship too late. And I think there's a lot of truth to this. It's really compelling to want to, polish your product a lot and just make it perfect and then get it out the door and be really proud of what you shipped. But in the reality, at a really early stage company, that's a recipe for failure. You probably don't actually know all the details of what you need to build until you talk to lots of customers and see them use it in practice. When Scarf first launched, it was a package manager. It was a system package manager that would kind of collect these stats of things that people would install on their machine, and it would kind of report things like crashes and exit codes and flags, and the developers could see those stats and use them. What we work on today is super different, and and the only way that we learned these things was by putting things out there, talking to people who are using them, and iterating. And so it would have been a huge mistake to really polish up that code and make everything really nice rather than shipping and talking to customers. Another thing that we talk, this is kind of like a term that has been coined internally at Scarf of Haskell brain. And what we mean by this is that there's a lot of things about Haskell that can encourage developers to seek really beautiful and elegant solutions rather than pragmatic ones. I think this is something that I think you'll see in any language. It's not unique to Haskell, but I think Haskell kind of naturally pushes you towards this kind of thinking sometimes. It's sometimes really compelling to come up with the perfect way to model your problem, and once it compiles, it works. This kind of really enjoyable programming experience, but that's not necessarily the right way to solve problems for the business. And so, you may come upon something and someone says, we can model this with type families, but then your build starts to take a super long time. You may be seeing a lot of problems with your CI pipeline and thinking, okay, if we can actually have a purely functional build and it's going to be lovely. And we did this. We wasted a lot of time doing this, and the reality is it just did not solve our problems, and it actually just wasted a lot of time. There's the really common, make illegal states unrepresentable, and that's a lovely idea, but you may still have exceptions at runtime, even though we might like to pretend that's not going to happen. And so you might be really proud of your solution, and it just crashes, or it just doesn't handle a case that you didn't think of. And I think that's a really important piece of this, because Haskell can be a really great tool for building what you spec'd, but sometimes the spec is wrong. Sometimes the spec did not cover some other case. You didn't understand your domain as well as you thought. There was an edge case that you didn't realize was there. And even though you thought you had considered every case and every corner case, you probably didn't. And so, when we see internally, when we see people kind of jumping into like a very complex yet elegant solution, kind of the joke of Haskell brain comes up. Another problem, I think, is that there's really not one way to write Haskell. This comes up a lot with the monad transformer topic of like, what's the right way to do monad transformers in Haskell? Do you do MTL? Do you do free monads? What is the effect system du jour? Or should we just stick it all in the IO monad and just move on with our lives? This is one of those things where you might look at this and say, oh, well, just pick something and move on. Have good engineers and move on. But not only is it a problem to having this conversation takes time, right? You might make a decision, and then a year later, this topic will come back up, and you need to rehash it because there's an engineer that's really a huge fan of free monads or whatever it might look like. And having all of these different ways to do stuff in some ways is really nice. There's a lot of ways to solve your problem, but it also means that there's a lot of ways to solve your problem. You have to choose again. And I think just decision fatigue can really quickly become a problem. But overall, it looks like maybe there might be some changes in this kind of thing. I know, like the Haskell Foundation existing, I think is definitely going to be a really good force. There are companies that are working on certifications for writing Haskell, and I think these kinds of initiatives can help establish more standards here. And so I think that this critique of having kind of no one way to do this may be getting better and better over time. But I think the overall ask here is that if we had better kind of agreed upon right ways to write Haskell, it gives teams something to fall back on if there's decisions that are not really ultimately very important for your business, but maybe people care about a lot. Just checking time. Yeah, and so I think other drawbacks that we've seen practically. I think that so these are just quotes from engineers that, at Scarf that I was kind of asking about, what's been bothering you about Haskell. This was another quote from Alex on our team. This is a GHC contributor. Still having these times where you just feel like, we have so much code. It all needs to do, we need to log stuff everywhere. Like observability of a production system is really important. And so you need to log stuff everywhere. And so now everywhere doesn't really look much like pure functional programming anymore. Query, you might need to hit the database in spots you didn't necessarily expect to. And before you know it, you don't really have all that much pure code, and you're just kind of back to writing imperative code. And the other thing is just Haskell is hard. I think it's fun to get good at. It's fun to write. But even really experienced Haskell engineers are still not always going to know if you should fold L or fold R. They're not always going to know if something should be strict or lazy. If a space leak comes up, it's still really hard to pin it down. And I think that's just something where, again, there's the more standards for how to write good Haskell will help. Obviously a bigger pool of engineers will help, but at Scarf, it's only senior and above engineers. These are really experienced people who've been writing Haskell for a long time, and still in practice, these engineers are sometimes feeling like they're kind of fighting Haskell to get their work done. Not that wouldn't be the case in some other language, but it's also the case here too. And so I think overall, you're going to be dealing with more accidental or unexpected complexity. You want to pick some tech, but it just doesn't have the Haskell bindings you want. Or you want to pick a vendor, but they don't have a Haskell SDK. The build, the picking these kinds of things, these are all things that detract from what you're really trying to do. They'll all make you have to work a little bit later every time you encounter them, and those things add up in practice when that's the life that you are living. And so, yeah, so why did we pick Haskell? This is a lot of complaints. Why did we pick it, and why have we stayed with it after all this time? And I think one thing that is really important here, on the original points that I was making about what is a reasonable criteria, agility and being able to refactor your code quickly is extremely useful. Like I said, we had a very different product when we started, and many, many iterations are taken to get towards a product that has customers, that has people wanting to buy it, and people wanting to stick with it. And so being able to have your system in production, make changes to them, let the compiler guide you through those refactors, and then just have it immediately be working is a really incredible experience. And I've never worked in a language that had it that had that kind of effect to the degree that Haskell does, where I could really take a step back, look at our types, switch the types around to map to kind of the new reality of based on something that we learned from customers, and ship and move on. And so the refactoring story in Haskell, I think, is world-class. And so if you don't really know exactly all the details of what it is that you are trying to build, Haskell is one of the best choices that you can pick for that particular criteria. Another thing is the types and the documentation. When I was first learning Haskell, I really I loathed Hadoc and Hackage. My initial impression was like, why are there no examples here? Like, how am I there's hardly any docs. How am I supposed to learn how to use a Haskell library? And the more, the better at Haskell I got, the more I learned to really love the system that we have with Hadoc and Hackage. You can literally just read the type signatures, and you basically know how to use the library, which I think another piece where there's a bit of a learning curve to get to that point. But once you are, it basically means that most of the libraries that you want to use, you have a pretty good sense of how to use them just from looking at a couple function signatures, and you're good to go. Not only that, you don't even need to go to Hackage. You can just generate these kinds of things locally. And that's a really powerful tool in the tool chain, especially if you're getting started with a code base and you just want to kind of check out at a really high level what the modules look like and what functions are and where the entry points are. You can just run Hadoc locally, and you are good to go. And so even if you spend 0 time writing docs, which you probably are at an early stage company, you have actually some good docs, and new developers are not going to be, totally, out in the cold having no idea what to do, because you have great types, and you have great type signatures, and you have documentation from that. And you can always write more, but it gives the kind of the minimum threshold of documentation that you have is pretty good. But if I'm being really honest about why we picked Haskell, it's because it's fun. It's because I like it. Haskell is a very fun language to write. And for anyone who's ever played the game Dwarf Fortress, losing is fun. There's a million ways to die in Dwarf Fortress, but all of them are quite fun. And I think that's a really apt analogy for Haskell. I think the refactoring, having things kind of work pretty soon after they compile. This is just a fun experience of coding. It keeps the day a bit more enjoyable. And I think startups are a lot of hard work, and if you can have something that makes them more fun, I think that's actually quite valuable. And so, really, I did a lot of complaining here. And so my constructive asks for the Haskell community at large for how we can fix some of these problems is that ultimately the Haskell community needs to prioritize adoption. That means prioritizing tutorials and the on-ramp for beginners and the learning curve, the marketing materials. These are all really important things. We also need to prioritize compatibility and backwards compatibility and the stability of the language. Currently, if I write Haskell today, I have very little confidence that code is just going to run if I come back in 3 years. I bet it won't. It probably will not. That's not a good characteristic if you're trying to convince companies to bet this is our livelihoods that are impacted by this code working always. And so I think by prioritizing backwards compatibility much more, I think we will see more adoption in the industry. I think making more good libraries is another really important thing. I think there could be entire companies and dev shops that just build libraries for Haskell. You'd have one customer with us right away if you started doing that. And then establishing more standards about how to write good Haskell, I think, will go very far for helping hire and have things to fall back on and not have to make a lot of decisions internally about how you write Haskell. So I'm like right at time here. So to wrap up, ultimately, I think that your choice of programming language is not really going to make or break the success of your company, but it can really impact your happiness while you do it. And so ultimately, choosing Haskell will probably slow you down. In the short run, I think it's very likely to slow you down. And you can't really reason about the long term because you haven't proved that there is a long term yet. You're trying to make the case that there is a long term to optimize for at a startup. And so if you pick tech that is too much front-loaded on the investment, that may not be a very wise choice. But I think there's a lot that we can do here to make Haskell a very compelling choice for industry adoption, but the community needs to prioritize these initiatives. We need to prioritize backwards compatibility. We need to prioritize having more libraries and the on-ramp and the learning curve. We need to actually care and invest in it. And ultimately, despite all these flaws, Haskell is a very fun language, and if you have a team that's very good at it, you can definitely get away with it. Thank you so much.